In this video, we will discuss the networks, and the computer networks is a collection of computers and devices together. To develop a network, we need the devices also, we need the computers also, and these devices and computer are connecting via communication device or a transmission media. So it's maybe a transmission media used to connect the different devices and computers together. It may be one of our central device which is used for communication purposes. And why we go for communication, especially in computer communication? So we have a number of advantages when working with our computer communication. The first is the communication. We can communicate the different computer at a different geographical area very easily with the help of a network. And similarly, we can share the hardware resources. For example, we can share the server resources with its clients. So that is a very good example of sharing hardware resources. And one of the example is Google is sharing the hardware resources. They share us some of our particular storage area when working with Google email. So that is a sharing hardware resources, and that can be done with the help of our networks. The third advantage of using a network is sharing data and information. We can share a lot of data, we can share a lot of information with the help of developing a network and sharing software. Similarly, we can share some of our software resources with the help of a network. So here is the one of our example in front of you. In between you have a ring architecture that is one of a network topology. We will discuss these topologies in coming presentations. So you see here a lot of and servers are present here, and these clients are connecting with the one of our main storage area, and that may be the server of this organization. So every system, every computer is connecting with the help of a ring network, and they uses the resources of a centralized server. So that is a very good example of sharing hardware resources, sharing softwares, transfer funds, and this is one of example of a communication, and that communication is built with the help of developing a network. And what type of a network we choose a ring topology. It's a wired architecture. We don't go towards the some of our devices to connect all the clients with one of a central server. So that is one of example of using the hardware resources in terms of a cable. So here are the some of examples when developing a network. So we have three different types depending on the geographical area. The first category is LAN, that is a local area network, and this one is a limited geographical area. That's maybe inside a one building, it's maybe inside a one room. So it's depending on the geographical area only. It's not depending on the number of computers connecting in a one particular area. It's not depending on the number of clients at a one particular location. In a one LAN network, we may have two users or two clients. You may have 100 users. So a number of devices, number of computers are not important when working with a local area network. It's only depending on some geographical areas. And similarly, we have a wireless LAN is also a type of a local area network. Only the difference is that this is a wired architecture and this one is a wireless architecture. We can use a central device to communicate all the clients together. Metropolitan area network is the second type of a network. It's also defined with the MAN, and it can also be defined if you connect a number of local area networks together. So if you connect 2 or 3 4 local area networks together, so that becomes a metropolitan area network. And the example of a metropolitan area network is that if you connect the different universities together, if you connect the for example Air University with the Barrier University network, so that is a metropolitan network. Air University individually defining as a one local area network, and similarly Barrier University is also defined as a one local area network. But if you're combining these two networks together, so that becomes a metropolitan area network. And similarly, the third category in a network is a wide area network. And if you connect the number of LAN networks and MAN networks together, so that becomes a wide area network. So it's a combination of a different LANs, it's a combination of different MANs, and it's also a combination of different LANs and MANs together. So, and it's also called internet. So basically the wide area network is also categorized as a internet. Here are the sum of a network architecture. The first architecture you see here is a client server architecture or a network, and that is a very important architecture. So what is happening in this diagram, we have a number of clients. We have a 1 2 3 clients are here, and we have a one server, and all the three clients are using the services of a server. And what type of a services is here? Sharing the hardware resources. So we have just a single printer here connecting with the server, and with the help of a wire network we can these clients use the services of a server. So that is a very important architecture, and most of the organization use this type of architecture. And the second is a P2P network, peer-to-peer network. What is happening here? Again, network is used to share the resources, share the information. So here is one again example of one printer here sharing the hardware resources, and they develop a ring architecture. Look at this thing, this computer is connecting with this one, this computer is connecting with this next one, and this one is connecting with the next one, and the printer is connecting with the one of our PC. So they again sharing the hardware resources, system 1 2 3 4 system using a one hardware resources by building a one network. So here are the two examples, very famous example when working with the network architecture. The first one is a client server, the second is a P2P. We have a point-to-point or peer-to-peer connection between the devices. But what is happening here? There is no point-to-point connection. We have a one main server, and this server is giving the services to its clients. And this is the example of your Google. This one is the example of your Facebook. This one is an example of every type of a service provider you are using the services nowadays. So here's again describing the same idea, P2P communication, in which the hardware resources are shared. We have three different hard disks available in this diagram. So the system 1 is showing the hardware resources of a system 2, and similarly system 2 is sharing the resources of the other two systems. So every system is using the resources of other systems. So now we are moving to the network topologies, architecture, layout. They are categorized in the same way. So we have three basic network topology, and with the help of these three basic network topologies we can build a higher level architectures of our network. So the first topology is a star network. So what is happening in a star network? We have a central device, and all the systems are connecting with the central device. So this one is referred as a star topology. It looks like a star, so that is the reason it's categorized as a star network. The second network is a bus network. We have a main bus, and every system is connecting with this main bus and sharing the resources, sharing the hardware resources with each other. And the third one is a ring network. So Similarly, this is one of example of a P2P network. This is a peer-to-peer connection between the system, and again it's used for sharing the resources. So here are the some of our network topologies. The first one we discuss in this chapter is a mesh. The second is star, third one is bus, ring, and tree and hybrid. So starting from a mesh topology, before starting a mesh we have some of a pictorial representation of these topology. We have a bus here. These blue circles are the clients, and this one is a main bus, so that is referred as a bus topology. The second is a ring topology. Every system is connecting with the P2P link with the other device, so that is categorized as a ring topology. Then you have a star, one central device is giving the services to its clients, and then we have an extended star here. We have a hybrid here. It's a combination of a hybrid is a combination of a different topology. We have a star here, and we have a bus here. So this is one is a combination of different topologies with each other. And mesh is basically a connection of one device with the remaining device. This topology is referred as a mesh topology. So every device has a dedicated connection with its remaining devices. So how you define a mesh? Here's the one of a point you have to remember when developing a mesh topology. That is, the every device has a point-to-point link with the other devices, every other devices. So it's mean if you come here, so you can see this device has a one of a connection with this one. This device is one of a connection built with the second device, third device, and a fourth device. So it's a point-to-point link with the every other device. And nodes are the computers or clients. That means you have if you see here in this diagram, so you have a 1 2 3 4 5 nodes are here. So it's mean n is 5 in this case. So so the node must be connecting with the n minus 1 nodes. It means if you have a 1 node n, so it must be connecting with the n minus 1 nodes. So n in this case is 5 and n minus 1 is 4. So it means the device 1 is connecting with the 4 remaining devices when working with a mesh topology. And a fully connected mesh have a n into n minus 1 divided by 2 physical channels to link the n devices. So if you have a n5, then if you calculate the results here, so 5 into 4, that becomes 20 divided by 2, which means we need a 10 physical links to connect the 5 devices in a mesh network. And if you come here, so you can see 1 2 3 4 5 6 7 8 9 and 10. So we have a 10 physical links here to develop a mesh network. So that is the one of a formula to calculate the number of links when connecting the n devices, and maybe 2 and maybe 3 4 5 depending on the number of devices. And input output port, IO is the input output ports, so it must be n minus 1 input output port in each device. It means each device must be n minus 1 input output ports to connect with the remaining devices. So if you see in this device, so there is a 1 2 3 4 ports are available to connect with the remaining devices. So here is the again the example of a mesh topology. We have 1 2 3 4 5 6 computers. So in this example, n is 6, and number of input output port is of course n minus 1. So 6 minus 1, that's the 5. So each computer requires a 5 input output ports to connect with these computers. And the number of physical links can also be calculated with the formula which is n into n minus 1 divided by 2. So 6 into 5, that becomes 30 divided by 2, so that becomes a 15. So it's mean when working with the 6 device, we need a 15 physical links to connect these 6 devices together. So that is one of example of a mesh topology. Now we are moving towards some of our advantages and disadvantages in this application. So one of our advantage of building a mesh topology is a privacy and security. Why privacy and security? Because each device has a dedicated connection with the other device. There is no central device between these two computers. There is no other thing coming here as compared to the ring topology or any other topology. So you see here, if a device 1 wants to communicate with the device 3, so we have a device 2 in between. So a security is compromised in a ring topology. But working with a mesh, so each device has a dedicated connection with the remaining devices, so security is not compromised, and that is the reason it's a most secure network. And another advantage is that if one of a link got damaged, then it cannot affect the others. So for example, if our computer 1 is disconnecting with the computer 2 with this link, so this link is going to be destroyed, so this computer is still able to communicate with them this one with the help of a remaining link. So it sends the data towards the system 3, and then system 3 sends back the data towards the system 2. But in this case, the security is compromised. When a fully connected network, when we discuss a fully mesh connected network, this is a most or one of our secure network. And when the sum of a link goes down due to some disaster, so then the security is compromised. In this case, the security is compromised. Disadvantages: amount of cabling, that is one of our disadvantages when we're working with the mesh topology. We need a lot of cables to develop a connection between the 6 devices. You see, we required 15 cables to develop a connection between 6 devices. So that is one of our disadvantages when working with the mesh topology. And of course, we have a bulk of wiring required, and application, it's only applicable on a wider scale. It's not be good to connect a number of computer in a local area network with the help of a mesh topology, because in one local area network we have maybe a 500-600 computer, and to connect 500-600 computers with the help of a mesh network, so that is going to be a lot of wiring. We have required an amount of cabling. We have required a number of input output ports. A lot of input output ports are required, so that is not a handy to work with the mesh topology in a local area network. So that is the reason we go for a wider scale. For example, I give the example in a previous presentation. If you want to connect the different universities together, here and you here 3 different university at some same type of a geographical area, if you connect these three with the help of a mesh topology, so that is one of example of a wide area network. You connecting the different universities together, so that is a very good thing. And the connection topology you adopt to connect these universities is a mesh topology. So that is an example of a mesh topology. It's only applicable on a wider scale. It's not be handy, it's not be good to work with the mesh topology when working in a local area networks or metropolitan area networks.